Hi guys, and welcome to yet another Devcast. Today I'm going to talk about terrain shaders and tessellation of terrain and terrain loading and so on. Some of you may have seen some of my posts on this topic that I did like a week ago probably, and since this weekend is not so sunny weekend, I had pretty much time for some further experiments. And this devcast is targeted to further advance some discussion on this topic because I'm curious about your approach to terrain loading and especially on mobile, since all these experiments are targeted for mobile. So let's start. This is the terrain from my last post. And what it does is actually using custom shader for tessellation and for shading using height maps directly instead of using the polygonal mesh for shading and even shadowing as well. So the shadows and shading is calculated from the height map in not using the vertices or the geometry itself. So if I just like rotate the light, you can see it's shadowed in high detail, even though if I just go to wireframe, it's not so high detail anymore. And there is tessellation. I need to enable it. So let's go for max tessellation 332. This is the basic tessellation based on distance. So we don't really need tessellation in higher distance. So this is the basic tessellation I used. It's actually modified tessellation I used in the previous example because I used this distance based on an arbitrary point in space. So if you see my late demo, it was a point that if you control it, you could control the distance of the tessellation as well as the fall off of the tessellation. But now the point is actually the camera itself. So I've started to play with some further experiments. This currently, if I just disable the tessellation, is 30 by 30 grid. It is obviously pretty like symmetrical, as you can see, and that's not really a good type of geo you need for terrain because if I just enable this and go, the tessellation is too greedy, as I would say, because the grid itself without the tessellation actually doesn't take into account the height. So I started to play with using Machina to play with some different approach. What I'm doing is I'm using remesh. Let me open this so it's targeted. I'm using remesh to remesh the grid terrain into a better geo, but this geo is quite dense. But as you can see, it already has like better. Uh, it doesn't really pop up as much. It has better geo to start with even without the tessellation. But it's kind of you can see right away that it's kind of like too dense compared to to this original geo, and it also doesn't really need that much triangles, especially for some areas. So what I did is I actually used the mountain node to displace the geo, the remeshed, because this is as you can see, this is just a plane. So I used mountain to displace it with the same height map that I'm using in the shader later, and then I'm reducing this geometry. Now you can see if you compare, I can just enable, I don't need to skip it, I can just enable template. So now you can see the templated, the pink one is the high dense geo, and the green one is after the reduction. And what I did to this reduction node is I created a new type of reduction heuristics, because these are pretty much the standard heuristics you can see in other 3D software. and Machina already supports them. But I wanted some different heuristic, and I named it edge steepness. And what it does, it reduces the geometry based on the steepness of the actual edge. So it encounters an edge, and it knows if it's going to reduce it based on the value of the steepness. So if I change it now, you can see that only the edges, really steep edges are kept in place. All of the others are reduced. So you can play with this, and we will play with this in our scenarios as well. So you can reduce this geo as you see fit. And if I just enable this, what I need to do actually, because now if I just enable the shaded one, it's really not that good because it's displaced 2 times. Actually, because it's offsetted in the geometry itself, then it's offsetted by the shader, and the reaction and the mountain node also just basically screwed up our UVs. So what I do here is just flatten the geo, because I just used it for reduction. I actually could do some custom node for reduction that would, instead of just working on the geometry itself, could work the reduction algorithm based on heuristics from the height map. But I wanted to just, this is more of a streamlined solution if you use Machina for geometry. So it just basically displays the geo with the height map, and then reduce the geometry instead of working with the geo based on heuristics from the height map directly. It could save you these nodes, but it's a too custom solution. Now this can be used by anyone using another use cases as well. But now I want to transform this, so I just scale it by 0 in the y direction, so it's flat again, so the displacement will happen in the shader. And I also use the planar mapping to fix the normals, because it's basically very simple, not normals, the UVs, because it's a very simple plane. So I just remapped the UVs once again using a planar mapping. So now I can go to wire shaded. It's displays, the UVs are fixed, and now the popping is not so predictable. I can go there here. As you can see, it doesn't like pop in an uniform manner. What's happened with the grid? If I can go here, you'll see that it just pops in a uniform manner. Now the details are already in the base geometry are way better, and the popping is more predictable, and it's more in line with the displacement of the mountain, or how to say it. So that's what I did, and as you can see, you saved a ton of geometry in these flat spaces. So I kept this in mind, that we just want to work with the steepness, and I implemented the steepness into the shader as well. So now if I just enable this, it will also use the steepness calculation from the geometry, even from the tessellated geometry. It will actually in the geo shader, in the domain calculation, it will decide if it should be tessellated based on the steepness factor for each edge. So if you have a patch of 3 vertices, it is 3 edges, and each edge has calculated its own steepness, and it's tessellated based on that. So you just enable this, you can see that these flat are not as tessellated as these ones. So the tessellation is happening based on the steepness as well. So there is not as much geo popping up. It also takes calculation, the distance into the calculation. As you can see, it's not these steep edges are not tessellated. So I basically left the distance calculation as well, but it's also calculating with the steepness of the edges. No, so I can just enable this, and as you can see, the popping is way more predictable, and as even this ridge It's there even with the base geo, and the details are just popping up a little based on the tessellation. Let me show you one again. I'm using the integer tessellation. I'm not using uh, the fractional tessellators because I don't think it fits for this, but I will play with it. Uh, but it's okay for this type of geometry. The fractional tessellators will not really help in our case with the predictable like greedy like displacement. So this is it. As you can see, it's fairly low poly. It's actually more low poly than the default 30 by 30 geo, and the tessellation is happening based on these two factors. What I will also play with and what I am thinking about currently is that we can, because the popping, most of the popping that's visible to the player is happening on the silhouette of the mountain. For example, like this stuff. So I'm also thinking that we can calculate actually how silhouette an edge is, or basically the face that we are calculating the tessellation for, because it's easy to calculate from the direction of the camera and the normal of the face, obviously. So I may take that into account in my further experiments, but in our case, in our game, we want a pretty much top down, not really a top down, but really like camera overseeing the scene from the top, not really going to these low angles. So I don't think it will help us that much. But once I know how predictable and how our camera moves, which we don't really know yet because we are playing with different prototypes, I can take that into account and work on the tessellation to fit specifically for that use case. But as you can see, these low areas with no steepness don't really need to tessellate. I can even go maybe further and reduce the poly count. And as I said, the lighting is correct because it's happening on the height map itself. Even the shadows are happening on the light map. You can see them there. Uh, this is the shadow. I currently don't use normals on the normal maps. I only have height map with the albedo or the diffuse map. So I actually calculate the shading and the shadows directly from neighbor samples from the height map. So I basically calculate the neighboring texels from the current texel in the height map and calculate the normals. So it's a lot of texture sampling that doesn't really need to be there if our height map is not dynamic. So we can cache the normal map with that. So we can either calculate it once and cache it, or we can provide it at auto time. But to play with just the different scenarios, I currently I'm calculating the normals from the height map as well. So that's pretty much it for this weekend's experiments, and I'm looking forward to any feedback. I may provide the shaders later if I finish them. We'll see. But currently, I just want to discuss this with anyone that's interested in loading and tessellating terrains on mobile. Yes, this works on mobile. It needs OpenGL AS 3.1 with AEP extension, but it's working on my all of my mobiles. I actually tried it on 3 of them, and it's running pretty smooth. Keep in mind just the terrain, but it's targeted for mobile. It's not really desktop. We need mobile. So if you want to discuss this, keep in mind that I want to target that type of hardware because there are some stuff that I wanted to try. I even tried vertex displacements and stuff like that. I actually ran it on mobile, but it was so the performance was not really good, so it doesn't really help in our cases. because I wanted to use it for some stuff like overhangs in terrain, but we'll see. Currently, this is what we are working with, and I am looking to any feedback. Thank you, guys.